This is for Year 12 methods, and it's some background work to enable you to complete Exam Focus 20 Part D out of exercise 4.6. And it really is in the family of questions of show that. And I'm going to do another example that hopefully will assist you in then completing Exam Focus 20 Part D. Let's say f of x equals e to the x. I have to show that f of uv doesn't equal f of u times f of v, but that f of u plus v does equal f of u times f of v. Now in these questions we have to show that the general form, that the function equals something in one case always and doesn't equal something else in another case always. I can't pick numbers to sub in, because if I pick numbers to sub in, that doesn't prove for all cases. What I need to do is to use the letters u and v, algebraically sub them in, and find out whether the left-hand side equals the right-hand side. And then it will for all values for u and v. Okay, let's take the first one. I know that f of x equals e to the x. Therefore, f of uv will equal e to the uv. F of u will equal e to the u. F of v will equal e to the v. And f of u plus v will equal e to the u plus v. So let's prove that this does not equal that. So f of uv does not equal f of u times f of v is what the proof that I need to show is the case. This is that. So e to the uv does not equal e to the u times e to the v. E to the uv does not equal e to the u plus v, which is using the first law of exponentials. That is not the case. Since the left-hand side does not equal the right-hand side, then f of uv does not equal f of u times f of v, and that is my showing. The form of the left-hand side is not the same as the right-hand side. So if I subbed in values of u and v, for example, if u equaled 1 and v equaled 1, my left-hand side would be e to the 1. That does not equal e to the 1 plus 1. I could think of values of u and v where it did equal. For example, if u equaled 2 and v equaled 2, my left-hand side would be u to e to the 4, and that does happen to equal e to the 4. It worked on that occasion, but there'll be other values of u and v where it doesn't work. So the left-hand side has to be the same form, identically the same as the right-hand side. Okay, that's my showing that this did not equal. How do I show that this does equal that? Okay. F of u plus v equals f of u times f of v, and that's what I need to show does exist. This is what f of u plus v is. E to the u plus v equals e to the u times e to the v. That equals e to the u plus v. Notice that the form of the left-hand side equals the right-hand side. Therefore, I can say that f of u plus v equals f of u times f of v when f of x equals e to the x. And that's true for all values for u and v. Now hopefully you can then go and look at 4.6 question number Exam Focus 20 and be able to substitute u's and v's into that more complicated expression, and if they are equal, then the left hand side will equal the right hand side.